Okay, so this is for part 2 for exam 2, and this is the second video. So we're going to go ahead and put P here, and then put a new line of code and define function Q 0. So we're going to say Q underscore 0, and then our internal P with a colon, and then our global heads, so overall ones, our net Q, our flows, and the P, and then P bracket for internal indices, close that bracket, and we're going to set that equal to our internal P. And then our heads are going to be equal to our pressure over rho over acceleration due to gravity plus our z. And that is going to be for, so I in range of the number of type and types. Then our delta head is going to be equal to our heads, and then bracket 2 node I minus heads in the from node, okay. And then our last line for this will be our flows, and then I in brackets, and we're going to set that equal to our flow parentheses delta head, our lengths I, our k, given k value I, and then our pipe diameter I, and then our pipe roughness epsilon over d I. Alright, next we're going to do our net q.fill, and that's set to 0.0. We're going to do our np.add function at net q to node, and then our flows. We're going to do our np.add at, and this is for the from node, so our net q from node, and then our negative flows. Then after all that, we're going to return our net q, and then our internal indices. Okay, let's run that, make sure that it checks out. Alright, we have one error, it looks like. Oh, it should be a underscore. Let's see if that. Alright, that solves it. Let's add the next line. We're going to set our res equal to our root q 0 and q to 0, And then from there, we're going to do our internal p underscore des. Alright, let's run that. Oh, shoot. Oh, oops. Again, underscore. Alright, and then for our final line, we're going to do for I in the range of n nodes. And we're going to have it print our f net q. And then our net q I 9.5 f, and then we're gonna have pi 9.0 f. Close that. And have it print for I in the range. And then it's for the pipes. Have it print f. Then our from node I to our to node I and our flows. Same thing. 9.5 f. Close that, and then we'll say meters cubed per second. Okay. Alright, let's go ahead and run that. And those are the values that are returned. So those are the calculations that are set up in order to find the net flow rates and the root findings in order to constrain the net flow to 0. So that is the end of exam 2 part 2.